Thank you, Danielle, and welcome. This is Edward Williams speaking, and here is a typical roadmap towards success with any and all simulation studies, whether they be of warehouses, manufacturing plants, hotel registration desks, hospital emergency rooms, health clinics, truck terminals, or airports for today. And with simulation, you have a great many. They're listed here, capabilities of high analytical power. Analytical tools can handle some interdependencies and just a little bit of random variation. Computer simulation is better than closed-form analytical tools, better in the sense of being more powerful and also easier to apply in many cases to handle complex systems with interdependencies and high variability. With simulation, you have these advantages. An animation is typically included at very little extra cost in either money or time, and you can get customized performance metrics and compare them statistically, such as hypothesis testing and confidence interval building, under different alternatives to be considered. Now, our simulation software range covers this. There's 12 tools here that we use. We're not indebted to any one tool. Everyone here knows at least 3. I know 5 of them, but then I'm one of the older guys here. Been here 14 years now. And which tool is the best depends heavily on detailed questions we ask the client before beginning a project. In fact, we have another webinar we offer periodically on how a particular simulation project might select one of these tools. Now, coming particularly to airports, today's topic, these are typical requirements both for the airport and the airplane. As the cynics are saying nowadays, how many sardines can we fit into this tin can? And will they be, well, comfortable? That's a pretty optimistic word lately. Under both the aspects of physical capacity, moving passengers in and out of the aircraft, and moving the aircraft in and out of the airport with highly volatile demand. Think of Thanksgiving, Christmas, holidays, summer, travel rushes with slack periods in between. Well, that brings us to this LOS concept, level of service. Qualitative covers things like comfort, how much of a hassle is it, are people safe, and do they feel safe? The quantitative assessments include things like average length of a waiting line in terms of number of people at the check-in desk or number of aircraft on the taxiway, or they've just arrived and they're waiting for a gate. Average number and also maximum number. It doesn't help much to have the average number small if the maximum number exceeds capacity, so that you have one queue interfering with another queue. They get all tangled up. And from the person's point of view, very important quantitative assessments are in time. Average time and maximum time waiting in a line, such as at security or at baggage claim or waiting to take off after the airplane door is closed, waiting for the jetway to dock after the airplane pulls in so that you can jump out of that tight, cramped seat and make a dash for the baggage claim so you can wait for your baggage longer. So all of these are very significant parts of level of service from the viewpoint of passengers and also from the viewpoint of pilots and airline personnel. And here are some of the draft standards in detail. We can go over these. You can read them when we put slides up on our website later, or on request we can send you these slides for blow up. These come from the International Air Transport Association, and they cover many different aspects of how to measure level of service. Well, there it doesn't look so good, does it? That's not so good. You can do questionnaires. Delta Airlines, we have a hub here in Detroit. They send me a questionnaire after almost every flight. Now, you can't do observations before the system's built, but usually these days airports are already built and they're already over capacity. The typical airport, it's said nowadays, was operating beyond its planned capacity beginning the week before it opened. And there's various static calculations that we use in these studies, and way beyond static calculations, such as might be done in a spreadsheet, is a simulation model, complete with animation, giving clues in the animation where the bottlenecks are, plus resulting statistics that represent predictions for level of service when proposed changes are made in the design or operation of the airport. And that's where the interactions come in. It might turn out that design change A will be of very little help. Design change B will be of very little help, but both design changes, if they were made simultaneously, they have a synergistic effect and would produce a highly significant improvement. That's an example of an interdependency. And simulation analyses are really good at sniffing out and exposing such interdependencies. Now, when a simulation project is being undertaken, these are some of the factors that are being considered. There's a list of 7 here, and it wouldn't be too hard, they won't fit on the slide, but it wouldn't be too hard to get this list up to 70, but this would get your thinking started. For example, number of accompanying visitors. I've experienced that myself. If I have to take a relative who is handicapped or walks very slowly or has poor vision to the airport, or as I've done on occasion, if I have to meet a visitor coming to my home city who does not speak English. As I told TSA once when I needed a concourse pass, even though I wasn't flying myself, well, my visitor is from Hungary. He doesn't speak English, and I'm going to guide him. The TSA guy said, well, do you speak Hungarian? No. Well, how are you going to be any help? Well, we'll both speak German. We both know that. That's an interesting situation. How many carry-on bags? Will they all fit in the overhead bin? Well, no, they won't. As the humor columnist David Barry once said, one of the travelers brought a grand piano on board, and he got it into the overhead bin after only 7 hours, 30 minutes of shoving it into the bin. And with increased fees for checked bags, more people are squeezing more and bigger carry-ons onto the airplane, which increases the boarding time and the time to get off the plane. And it can cause airplane rage too. That was my overhead bin. It's above my seat. And even before you get to security check-in and ticketing, well, if the airport is lucky, most of the people will check in and print out their boarding passes online. But you still can't check your luggage online by shoving it into the computer monitor. So this is a typical problem I see crop up at every airport I fly to. You have some service at curbside, some staffed, some self-service, some inside the terminal. Then an interesting issue comes up, balance between curbside and inside the terminal. Well, that balance can be different on a bright, sunny, pleasant day versus a bitterly cold day versus a rainy day. In the latter two, more people want to go inside, and that affects the demand ratios. And then will there be enough space to hold the queues? And how do you schedule the agents? And what will the waiting times be for a given future demand? Certainly with the economy improving, I see articles on newspapers and internet news weekly, sometimes it seems almost daily, that a particular airline is planning a new flight or more frequent service on a flight between city A and city B. And from the point of view of the president of the airline, there's always room for one more flight at the airport. The one getting attention recently is from Dubai to San Francisco, and that'll be a new long-distance flight record. So how is this going to affect future demand? Interesting questions. Well, after check-in, then comes the security screening checkpoint. Well, secure, we hope it's secure. What effect does it have when TSA pre-check is used at different levels? What effect does the mix of travelers between, let us say, experienced business travelers who know the drill versus very occasional once-a-year vacationers who aren't as familiar with the drill versus elderly or handicapped people who need more time and security versus people who don't speak English fluently and can't necessarily read all the signs that TSA puts up at security. And then you have this issue, and studies are saying lately the length of a drive that people will make. In order to avoid getting on a plane, would I drive 200, 300, 400 miles, etc.? That number has been going up lately. And a competitive airport does not want to lose business of the traveling public to other modes of transportation, such as private automobiles or long-distance buses. And what is the impact of new technology, such as I have my boarding pass on my cell phone? How does that affect performance criteria at the security screening checkpoint? And after people get through the security, then it can be an interesting simulation study. How wide are the corridors? Is it easy to go around a corner in a wheelchair? Well, not if the corner is sharp. Preferably it's rounded. Do the queues for getting on board the plane interfere with the queue waiting to get into the bathroom, especially if the bathroom down the hall is closed, or with the concession stand and so forth? Where should the water fountains be? Well, from the viewpoint of plumbing, they should be near the restrooms. But is that the best situation relative to pedestrian circulation within the concourse? And it isn't entirely pedestrians. You might have moving walkways. You have the little carts that go beep, beep to get people out of the way as they take people who can't walk long distances and so forth. So there's very significant problems come up inside the concourse, what's called airside as opposed to landside. And likewise in holding rooms. Well, if there's a long delay, are the number of seats at the gate sufficient to hold the number of passengers waiting to get on that flight? Well, if not, could we borrow the adjacent gate that flight left? And if flights are delayed, for example, what happens, a particular one from my own experience, I've already left a foreign country in the sense that my passport now has an exit stamp on it. And I have only a single entry visa. I cannot just walk back in. If the flight's delayed for 6 hours, well, yes, there'll almost certainly be a bathroom, and it's going to be overused and get unpleasant, to say the least. Will there be a restaurant? Will there be a place to lie down? Will there be a drinking fountain where I can take medication? All of these are very significant issues, particularly if an airport is going to have or expects to support international travel. And for safety reasons, the federal government of any country, not just the United States, has to look at this, run federal inspection services that the airport has to pass. For example, if there were a fire or a bomb went off, or there was a smoke scare or a tornado warning, could everyone get into a safe place adequately? Would the safe, secure area, like a tornado shelter, A, would it even be big enough? And B, could everyone reach it in time? These are very significant problems to handle dangerous contingencies. Oh, and now we come to everybody's love. Just look, oh, we can all relate to this, right? Just look at the baggage claim area. You should see what happens. I've seen as many as 3 flights unloading to the same big conveyor. Well, of course, every passenger wants to be right beside the moving conveyor belt so that he or she can see the bag coming from halfway around the conveyor. Well, every passenger can't be in that position. How long do they wait for their baggage? Well, longer than they want to. And no, the second bullet point, everyone can't be right in front of the conveyor. And is it correctly sized? Well, it probably should be bigger. Maybe it should be bigger than will fit in the whole baggage claim room. Well, too bad we didn't make the baggage claim room bigger 50 years ago. So what is the impact of new control logic? And if this equipment is changed, future growth, well, the growth that's already taken place, the cynic would say, let alone future growth, and what changes might be required as a result of changes, more stringent regulation. And, oh my, well, haven't we all waited in an airplane that was all buttoned up, as the pilots would say? We're all buttoned up, ready to go. We're just waiting for the ground crew to get here and push us back away from the gate. Or on arrival, we're right here, right beside the jetway, and the airport, inside the terminal, they're screaming for somebody to come and push the jetway out to dock with the departure door on the aircraft. And not every airplane will fit at every gate. That's hardly likely. And what about all the taxiing? So all of these, like modeling inside the concourse, the check-in, the security, the aircraft movement, there's ample opportunity for very productive simulation studies that can yield very significant improvements. Now, this is really very good. That's unrealistic. Usually, in a photo like this, the cars would already be double and triple parked, with a policeman screaming at them that if you hover here waiting for your pickup, have another 15 seconds, I'm going to ticket you and boot your car. So is there enough curb frontage? Well, no, there isn't. People have hardly ever seen, quote, enough. And what measures are necessary to reduce congestion on terminal roadways? Well, at least we're realistic enough to put this word reduce in. We could have put in the word eliminate, but we woke up from our pipe dream and made the word reduce. And likewise, what is the breakpoint capacity? So all these fascinating studies, we've done simulations of some of these already for various airports. Some of the airports are the commercial ones. Others are what might be called more local airports, whose large amount of service is private jets for business people. These ideas apply equally well and can be equally beneficial to all types and sizes of airports. So thank you, Danielle, and we can open it up for questions now. I'll be glad to take some.